Hey everybody, today's lesson is 3.2, starting a new chapter, and this is actually called synthetic division. And basically what synthetic division is it's an algorithm, and it allows us to divide a polynomial by a binomial. So important word here is that this actually must be a binomial. Okay, so notice how we have a binomial down here, binomial, binomial. You can't divide by anything else using synthetic division, just beware of that. But it's actually going to be really, really useful. You guys are going to like this a lot. And another really important thing about synthetic division is that the coefficient of x, when you're in the divisor, must be 1. So notice again that like down here, all of the coefficients on the x's are 1. And the third important thing here is that you must fill in zeros for any missing terms, okay? And so basically what I want to kind of review with you is, do you remember at the very beginning of the year when I gave you a problem that looked like this and I told you to divide? Do you remember doing long division? Because I'm pretty sure you're going to like be rolling your eyes and like, oh my gosh, that sucked so much. Okay, so here's what we did. Don't write this down, just watch. Remember we had to go plus 0x squared minus 4x plus 2, and we were like, how many times can you multiply x by to get 3x to the third? So you go 3x squared, and you distribute the 3x squared, and you subtract everything. Do you remember this process? This is the old way of doing division. I'm going to show you a new way, which is so amazing. You guys are going to love it. Let me erase all this for a second. Alright, so here's the trick. Basically what we're going to do is the way that you start these problems is by equaling the denominator to 0 and solving. So when you add 1 to both sides you get 1. And this 1 is actually the number that goes in the, I call it the backwards L box. And it's kind of like a division symbol that's been flipped or reflected or something, but that's how you figure out what number you're dividing by using synthetic division. And then what we're going to do with these coefficients, the 3 and the -4 and the 2, is I'm going to line them up like so. Remember how there wasn't an x squared term, so I have to put in a 0 for the x squared term. And this is going to be my division setup. Okay, so basically what you do first, just to reiterate, you set the denominator equal to 0, and that number is what goes here. And it's kind of in your little box. And then all of these coefficients, including any zeros for any missing terms, go here. So it's a little bit easier to write than the entire problem because you don't have to write any of the x's. You're just using the coefficients. And you guys, you're going to get so fast at this. This is so awesome. What you do first is you bring down the 3. And then you multiply the 3 by the 1 and you put it here. And then what you do going down is you add. So I'm going to write 0 plus 3 is 3. And now you do it again. 3 times 1 is 3. And then you add. And then you multiply -1 times 1. And then you add. Okay, so what did this do? What did this tell us? Well, basically, you guys, this is the cool part, is that all you have to do is decrease the exponents by 1 for the division. So you started with x to the third and you divided by x. That means that we're going to fill in x squared plus 3x minus 1. And this is the remainder. Okay, and remember how we write our remainders? You always write it as 1 over what you divided by, which is x minus 1. So it's way, way, way faster than doing long division, and so much easier to do as far as like with the negative signs and like remembering to subtract and multiplying correctly. So much easier. So we started with x to the third, therefore when I had to fill in all my x's down here, I started with x to the second. Because when you divide, you decrease the exponents by 1. Okay, let's try another one. Where's my next example? Oh, it's down here. Okay, good. So remember how we start. You start by equaling the denominator to 0, and that gives you x equals -4, and that's what I'm going to put in the backwards L box. And now I'm going to take my coefficients and line them up. Notice how I'm not missing any terms in this one. I don't have to fill in any zeros, but that's the same exact way as if you were doing long division. So 1x to the 4th, 4x to the 3rd, 2x squared, 9x, and 4. Draw your line, start by bringing down the 1. And now you multiply. 1 times -4 is -4, and add. So 0. And then multiply. 0 times -4 is 0, and add. So we get 2. And multiply. 2 times -4 is -8, and add, which gives you 1. 1 times -4 is -4, and add, which means we have 0. And again, remember what this means, or what did we just find, what did we just do? Remember, this is the remainder, the last number in the long division, or synthetic division. And what does it mean to have a remainder of 0? Doesn't that mean that it divides evenly and there is no remainder? And so, again, now I just have to fill in the x's. This problem started with x to the 4th, so I'm filling in x to the 3rd. 0x squared, 2x. And I don't need the remainder, it's just 0, so I'm not writing like plus 0 over x plus 4. That's it. So basically my final answer, you don't even need this 0 either. If this was a math Excel question, you would just type x to the 3rd plus 2x plus 1. There is your answer. So it's really, really fast. You guys will get so fast at it. Okay, how about this one? This one has a little bit more numbers, but again, we're still setting this up the same way. Start by equaling the denominator to 0. That gives you -2. That's what goes in the box. Take all your coefficients from up here. Notice we are missing x to the 5th. So in that spot, I need to put a 0. So we're going to go 1, 0, -3, 2, -6, -5, and 3. So a lot of numbers. Start by doing 1. And again, where did those coefficients come from? The 1 coefficient is here. There was no x to the 5th, so I had to put in a 0. -3, 2, -6, -5, 3. That's all of these numbers here, just the coefficients, no x's. So now I'm multiplying and adding. You always just multiply and then add. And then multiply, add. Multiply, be careful, multiplying by 0 just gives you 0. And add, don't make any silly mental math mistakes here. Add, -14, -11. So if I'm writing my final answer here, this is actually kind of a lot of x's and stuff. I started with x to the 6th, therefore I'm filling in x to the 5th, x to the 4th, x to the 3rd. I don't need the x squared, x, 7. And my remainder is -11 over x plus 2. So that's how you're typing your answer. We have x to the 5th minus 2x to the 4th plus x to the 3rd minus 6x plus 7 plus -11 over x plus 2. There's our final answer. So it kind of sucks to fill in all the x's. It's a lot of writing, but you guys, isn't that so much easier than doing long division? Okay, there's one other thing that synthetic division can help us with. Actually, there's a gajillion other things. We're going to talk about one more in the notes here today. But basically, let's see, one question that I could ask you it's called the remainder theorem. And what this means is that it's asking you to plug in -1 into the equation. And yeah, you could probably do the -1 into the equation. So you plug it in here, you plug it in here, you plug it in here, and you just combine your like terms. That's kind of what we did in our last chapter. But think about doing -1/2. That one would kind of suck a little bit, wouldn't it? Because you have to plug it in, cube it, multiply by 4, plug it into that, square it, multiply by 8. So like that is not very timely. And yeah, you could do it, or especially you could do it in a calculator, but let me show you how easy synthetic division is when you do that. So this is another useful part of synthetic division. So basically, notice how there's nothing that I need to equal anything to. They're already telling me what k is equal to. So that is the number that's going in my box. And I'm going to do synthetic division again. 1, -1, or whoops, -4, 2, and 1. And there's no zeros that I need to fill in because all of my terms, none of them are missing. But I'm just going to do synthetic division really quickly. -1, add 5, add -7, -6. Boom. There's the answer. Did you know that the remainder, if you divide, is the same thing you get when you plug in -1? This means that f of -1 equals -6. So it's a really, really fast way of actually evaluating a function. So let's do this one in our head so you can kind of prove that it works. -1 to the third is -1. -4 times -1 squared is just 1. And then when you plug in the -1 here, you get -2, and then +1. Can you add all this stuff up for me? -1 minus 4 is -5, -2 is -7, +1 is -6. Whoa. So synthetic division is way faster to be able to do the same exact math, especially you guys if it's a fraction. How much would it suck to plug in 1/2 like I said? So let's use -1/2 in the backwards L box. I don't need to fill in any zeros here, but I'm always checking for that. Let's see if we can do synthetic division so quickly. 4 times -1/2 is -2 and add. 6 times -1/2 is -3 and add. -4 times -1/2 is +2 and add. Boom, there's your answer. F of -1/2 equals 3. That means when you plug in -1/2 up here and probably use a calculator or anything like that, you can get the answer so much faster if you just do synthetic division. So those are the two uses we're going to talk about today for synthetic division, you guys. Number one is it's actually a much faster and easier and more likable method to do actual division. That's problem number one that we learned how to do. The second thing we learned how to do is to use synthetic division to actually plug in numbers and get an answer. So that's two things. We're going to learn a bunch more as the chapter goes on. That's all we got for tonight, though. Have a good night, and thanks for watching.